Now we talk about causality testing. So the first thing is, does the second variable cause the first variable? So we had a series, and in the series we had two variables, y1 and y2. So there was a variable y1 and there was a variable y2, and we saw that the y2 was part of y1. That is what our estimated equation showed. And we want to see that does this variable y2 actually cause this variable y1, and there is a test for it, and that test is called Granger causality test. So this question is answered using this Granger causality test, and the null hypothesis of this test is that there is no causality, and we will reject this null hypothesis if p-value is less than 0.05. So we will run this test and we will see that the p-value is actually less than 0.05, and that will help us reject the test. So you will get a p-value less than 0.05, and therefore you will reject the null hypothesis that there is lack of causality. And this is the test: causality estimate value cause y2 means does y2 cause y1. So let us see this in R. So let us run this causality test. You select this and you hit the run button, and you see the p-value is 2.2 times 10 to the power of minus 16. So it is way below 0.05. So you reject the hypothesis that there is no causality. So we reject the hypothesis that there is no causality. So a few words about causality tests. So there are many causality tests other than this Granger causality. This was the first one, and it is the most popular one. But you have to keep in mind this: all causality tests are wrong. For every test invented, there are many counterexamples showing that the test is just giving causality between wrong data series. Now the correct way to use these tests is that you should first have a strong evidence or intuition or an understanding for causality. So once you have that understanding and a strong economic intuition for it, say for example cast iron and wrought iron prices are linked to each other, then you can back up your evidence with some numerical evidence which is given by a causality test. But do not use, again this is a warning, that do not use causality test as a primary evidence of causality. So causality test is not a primary evidence of causality. So your own understanding is a primary evidence of causality. You have to keep in mind that this is applied mathematics, and applied mathematics is as good as, say, philosophy, because you're just expressing something in terms of numbers. That does not make it true. This is not pure mathematics that formulas and relationships are always true. This is applied mathematics. In particular, it is applied to economics. So your grounding and your understanding has to be there. What these causality tests are just going to do is provide you some kind of a numerical evidence, but this numerical evidence does not come from pure mathematics. This numerical evidence is just some tests saying that there is some causality. Even if you do the mathematics of it, it does not imply causality, because this causality lies in a different world and this numerical test lies in a different world. So there people have constructed many series which show that these causality tests are wrong. So this should be taken with a pinch of salt. But again, if you have a strong evidence, then you can always back yourself up with the numerical evidence. But do not use numerical evidence as the primary criteria, because this numerical evidence comes from applied mathematics. It has no basis in pure mathematics as such, because this causality lives in the economic world. It does not live in pure mathematics world, and applied mathematics is just trying to give you numerical evidence. So you have to keep in mind the distinction between pure mathematics and applied mathematics. What we are doing here is applied mathematics, so which can be false. It is false many times.